Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go over what we went through in week 12. So we started probability and we're looking at discrete probability distributions. So probability distributions look like this. It's just a list of outcomes and their associated probabilities. What makes probability distributions discrete is if the random variable can only take certain number of values, like integers. So this one is discrete because x can only take values 1, 2, 3, and 4. So what makes something a random variable? It just means the value that it takes is dependent on chance. So, in order for a probability distribution to be valid, both of these must be true. Each probability must be between 0 and 1, can be 0, can be 1, and probabilities must sum to 1. So this here is not a valid probability distribution because the probabilities add to more than 1. Over here, this could be a valid probability distribution if each of the probabilities added to 1. So all of these probabilities add up to 8k. So this will be a valid probability distribution if 8k is equal to 1 or k is 1 over 8. The probability is 1/8, 3/8, 3/8, 1/8. So sometimes probability distributions are listed as a function instead. This again will be valid if each of these substituted into the formula gives a number between 0 and 1, and also if I sum all those values I get 1. So we can put the information into a table. So if I sub 0 into this formula, I get 1 over k, substituting 1 gives 2 over k, and then 5 over k, and 10 over k. So once again, to get each of these terms here, I just substituted the number into this formula. So this will be a valid probability distribution if k is equal to 18. Because if I add all of these, I get 18 over k. If I want all of these to add to 1, k equals 18. It's a valid discrete probability distribution. All right, let's now look at mean and variance. So let's consider this probability distribution here. So this is the distribution I would get if I rolled a 4-sided die. So note that each outcome is equally likely to occur. We call such distributions uniform. So we're going to calculate the expected value or mean of this distribution. So to do that, we take each score and multiply by its probability, and then we add up all of these. So take each possibility, multiply by its probability, and add them all up. So if I do that, I get 2.5 as my answer. So you might be thinking to yourself, well, hang on a minute, 2.5 is not a possible value. If I roll a 4-sided die, I can't get 2.5. What it actually means is if I were to roll a die, a 4-sided die, over and over and over again, and then take the mean of each of the numbers I rolled, I would expect that to be 2.5. Of course, there's no guarantee that my mean will be 2.5. The degree to which observed scores differ from the expected value is measured by the variance and the standard deviation. So to calculate the variance of x, so we use capital letters for random variables and lowercase letters for the values they realize. So to calculate the variance, we need to calculate first this, expected value of x squared. So to calculate that, I actually need another row in my table. Each of these values will be x squared. So 1 squared is 1, 2 squared 4, 3 squared 9, and 4 squared 16. The expected value of x squared is calculated similar to above. We take each possible value of x squared and multiply by its probability. Each possible value of x squared and multiply by its probability. So if I add up all of these numbers, I get 7.5. So the variance of x is going to be the expected value of x squared minus the expected value of x all squared. So that number gives me 1.25. The variance must always be a positive number. So the standard deviation is just the square root of the variance, which is about 1.12. what does this number mean? It means if I rolled heaps of four-sided die over and over again and took the mean of my scores, if I did that heaps of times, I would expect, on average, the mean that I get from rolling the die heaps of times would differ from the expected value by about this much. This is like the average distance by which my mean, the observed score, will differ from the expected score. All right, let's now look at a harder problem. So in this question here, we're going to find the values of A and B. So the expected value of this distribution is 2.56. So the expected value here is going to be each score multiplied by its probability, and then I add all of those up. So just making this one easier to work with, I'll actually get 1.2 plus 2a plus 4b. Now, the question told us that the expected value was 2.56. So subtracting 1.2 from both sides, I get this equation here. So you should probably have figured out by now that if I want to find two unknowns, I need two equations. So this gives me one equation. So what would be the other equation? Well, for this to be a valid probability distribution, all of these would need to add up to 1. So 0.3 plus a fifth is 0.5. So my other equation is A plus B must equal 0.5. So it's probably been a while since you've solved simultaneous equations. We're going to multiply this equation by 2. We could have done by 4 as well, because multiplying this equation by 2 gives me this. What we're doing here is we want to eliminate the A's or the B's. We eliminate the one that has the same coefficient. Because in these two equations, neither A nor B had the same coefficient, I multiplied the second one. So now we have two equations where one of the variables, in this case A, has the same coefficient. So what we do for getting this equation is we're going to subtract everything. 1.36 minus 1 is 0.36. 2a minus 2a cancels out. 4b minus 2b is 2b. So we get B is 0.18. That means A is 0.32. How easy was that? Let's move on to combinations. So combinations are counting tools to help us with probability calculations. They count the number of ways you can pick R objects from a group of N. So we use this notation or this, either doesn't matter. This is the formula, though your calculator can calculate it for you. Just press math to get up the math menu and scroll over to PRB and you should see this option. So what do they actually count? Well, let's say I want to find the number of two-letter words I can pick from ACT. So I could pick an A and a C, an A and a T, or a C and a T. So for combinations, the order doesn't matter. It kind of sees AC as the same as CA and AT the same as TA, and so on. So I could have calculated this using combinations. 3C2 is equal to 3. There are 3 different ways I can pick 2 letters from the word ACT. So it was easy to count them in this case, but if you have a large number of objects from an even larger group to pick from, it gets big really quickly. So we're going to show how combinations can be used in this one here. So debating team of 3 needs to pick from 5 boys, 4 girls. What's the probability one boy is on the team? So it's going to be easier to find the probability of 0 boys and subtract that from 1. So the probability that I get 0 boys, it will just be the number of ways I can pick all girls over the total number of outcomes. So how many different ways could I pick 0 boys? Well, I'd be choosing all 3 people would be girls, and there are 4 girls to choose from. The total number of ways to pick 3 people from a group of 9 would be 9C3. So putting these on our calculator, 4C3 is equal to 4, 9C3 is equal to 84. So 1 minus 4 over 84 gives you 15 over 16, or 0.9375. That's the probability of picking at least one boy. This question was made so much easier due to combinations. I was able to calculate number of ways the event could occur and the total number of outcomes. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.